The title of this note is Solving Polar Systems, and your goal is to be able to find what are called the common points and the solutions of a system of polar equations. We're going to do this graphically and algebraically. Polar equations, you guys remember from last class, usually have sine and cosine in them. So we are going to be doing some trigonometry. It would be an excellent idea for you to look over your unit circle. It's on the back of your goldenrod sheet. In addition to your unit circle, you are going to need what are called double angle identities. You never have to know these. You'll always be able to look them up. There are 4 that you're going to need to reference. So go ahead and just copy these into your notes. Then how do we actually solve a system algebraically? So a system means you have 2 polar equations. You might have 2 circles, and I want to know where they intersect. So the first thing you're going to do is you're going to set the 2 equations equal to each other. Then your goal is to get only one trig ratio. Everything can be sine, everything can be cosine, or everything can be tangent. And you might need to use those double angle identities that you saw above. After everything is in all the same trig ratio, you're going to use your algebra and inverse trig to solve for theta. And then your last step is always to check your solution. So I'm going to show you a couple of these on the next slide. Okay, so here I have 5 practice problems. I'm just going to go through the first 4. We're not going to do problems like number 5. So first one, I have r equals 2 cosine theta. You can go ahead and use your calculator to graph these. R equals 2 is a circle centered at the pole with a radius of 2. R equals 2 cosine theta is a circle on the horizontal that goes out 2. So from the picture, I can see it looks like there's an intersection point there. And I want to figure out the theta value that gets that intersection point. So according to my notes, step 1 is to set those 2 equations equal to each other. So this is number 1. So the first equation is 2, the second equation is 2 cosine theta, set them equal to each other. And then I want only one trig ratio. Good news is here there is only one, it's cosine. So I don't have to do any trig identity stuff. So now I'm going to go ahead and use my algebra to solve. I want to get theta by itself. I'm going to divide both sides by 2. And I get that 1 equals cosine theta. In order to get theta by itself, I need to get rid of cosine. So I'm going to use inverse cosine. And that'll cancel out that cosine there. Inverse cosine just means what's the angle that has that cosine value. So what angle has the cosine value of 1? So if you go to your unit circle, cosine is x-coordinates, and I know that the angle that has a cosine value of 1 is 0 and 2 pi. You only need to give me answers between 0 and 2 pi. 0 and 2 pi are the same angle, so there's no need to write that one twice. So for the first one, the angle 0 is the correct answer. Now, remember, polar coordinates have an r and a theta. So what I want to do is I want to go back, and I want to put theta into the equation. So if theta is 0, then the cosine of 0 is 1. So r equals 2. And you notice, same r value. So the point of intersection for number 1 is at r theta, or 2, 0, which makes sense based on my picture, right? If I look at my picture, that point is the point 2, 0. Right, let's look at number 2. I'm going to erase what I have here. And number 2, same first step, I'm going to take the 2 equations and I'm going to set them equal to each other. Then I want to make sure I have only one trig ratio, which I do. I have sine theta. So now I am going to solve. So I'm going to subtract sine theta. Think of sine theta like x. right? If this equation was x equals 1 plus x, you would subtract x from both sides. Sine theta minus sine theta is 0 equals 1. Whoa, 0 equals 1. That's not a true statement. What do the graphs look like? Sine theta is a vertical circle that goes out to 1. 1 plus sine theta. We haven't looked at these. These are a limacon. But if you sketch it, that ends up being a vertical cardioid. And we're going to talk about this more in class. It looks like they should intersect at 0, 0, but they don't. This equation says, hey, they never intersect because 0 never equals 1. The reason it looks like they intersect is because we have this aspect of time. So we've talked about if these are planes flying. We're more concerned about when the planes are going to cross paths at the same time. It's okay for them to cross the same path as long as they don't do it at the same time. This is called a common point. It's a point that it looks like it's an intersection, but because they don't get there at the same time, it doesn't count as an intersection point. So we're not interested in finding common points. I just wanted to point this scenario out to you that sometimes in your graph it can look like there's more intersections than there actually are. So this one has no solutions. All right, let's take a look at number 3. So we have sine 2 theta equals 2 sine theta. Now, it looks like I have the same trig ratio because they are both sine, but the argument, that's the stuff inside the trig function, it's not the same. One of them is 2 theta and one of them is theta. So it doesn't actually count yet as being the same. So you're going to use one of your double angle identities. It's called a double angle identity because it's 2, as in doubling. So the double angle identity, and if you flip back to the angle, to the identities that you wrote down, you see that sine 2 theta equals 2 sine theta cosine theta. Okay. I'm a little uncomfortable. It looks like I made it worse. I have a sine and a cosine. But let me go ahead and try to solve. Notice that both sides have sine in them. So let me go ahead and divide that out. When I divide it out, I get 2 cosine theta equals 2. And that's good news because now I have just that one trig ratio. So I'm going to go ahead and finish solving. So I have cosine theta equals 1. So you're going to ask yourself, what values on my unit circle have a cosine value of 1? And those values are 0 and 2 pi. Remember, your answers are comma theta. So we know that the theta value is 0. 0 and 2 pi are the same angles. And then we need the r. So to find the r, you just have to put theta into one of the equations. So let's say I put in this one right here. Okay, so the sine of 0 is 0. So 2 times 0 is 0. So the intersection is at 0, 0. Again, you can graph it to double check. Sine 2 theta, that's a 4-petaled vertical rose. 2 sine theta is a vertical circle. And the only place that they're going to intersect is at 0, 0. We have one last one to show you. Number 4. First step, set them equal to each other. Okay, I have sine and I have cosine. I can't use any of my double angle formulas because it's not a double angle. It doesn't say 2 theta. Whenever you have sine and cosine, the trick that I want you to use is I want you to divide by cosine because you have an old identity that says sine divided by cosine is tangent. So the one trig ratio you're going to end up with is tangent. I'm not ready to divide yet. Let me subtract that 2 that's hanging out there. So 2 sine theta equals -2 cosine theta. Go ahead and divide by cosine theta. Whenever you have sine and cosine, you want to divide by the cosine because it creates sine over cosine, which is tangent. I'm going to keep going here to get theta by itself. So the tangent of theta equals -1. And so the theta values that have a tangent of -1 on the unit circle are 3 pi over 4 and 7 pi over 4. So this one has potentially 2 solutions. And we're going to write them as r theta and then you just have to figure out the r values. So go ahead and plug each theta into one of the equations. It doesn't matter which one. So let's say I plug it in the first one. 2 plus 2 sine 3 pi over 4. That is, I'm going to do it down here. Sine of 3 pi over 4, again, I'm going to my unit circle. It's radical 2 over 2. Those 2's cancel out because times 2 divide by 2. 2 plus radical 2. Don't worry about simplifying that. You're just going to get a weird decimal. And then again, I'm going to put 7 pi over 4 in. I'm going to erase some of this that I've already done. And when I put 7 pi over 4, again, going to my unit circle, the sine of 7 pi over 4 is negative radical 2 over 2. So that's 2 minus radical 2. So those are the 2 points where those graphs intersect. I promise we're going to do a lot of practice on this in class. Make sure you've looked over your unit circle because you're going to want to know those values.